Okay, so 14-6, it kind of looks a little more gnarly than it is, but we'll go through it. It kind of gives you an ANOVA table, right? And then it asks you for determine the standard error of estimate. It says about 95% of the residuals will be between these two values. So if you go back to the middle of page 484 and it's got the multiple standard error of estimate, that's the formula that we use, and they've kind of condensed it in a little bit and say that it's the square root of our SSE divided by n minus k plus 1. Okay, so the SSE is given to me if I look at the ANOVA table. And what the SSE is, if you go to the column, if you look on problem 5 there, if you go to the column that's headed by SS, the SSE is actually the residual error. So you go down to the one that says residual error, and where those cross, you can see it's the 583.693. So it's going to be that divided by n, or 65, minus k plus 1, or 2 plus 1. So really it's going to be this divided by 62, I believe, is going to be what that is. But if I do the math, it's equal to my SSE divided by parentheses n minus parentheses. Oops, what did I do wrong? N minus parentheses 2 plus 1 double parentheses. I should be good, right? So that's this total that's underneath the square root. Okay, and it's good to do it this way because you're going to need it down here. So if you do that before the square root, then all you have to do is take the square root of that, which of course we've done 100 times. Square root, boom, yep, okay. Square root of this number, okay. So it's 3.06. And so what that means is that, again, if you're looking at a table, and if you went to 34%, on either side of the midpoint, not a table, but that standard curve, that bell curve that we usually look at, okay, so for this particular equation, for this particular ANOVA, then it'll be plus or minus this number, right? 34%. So either to the left side or to the right side, this is the actual number that you'd come up with for this particular set of data. To get the 95% one, it's pretty easy. You just multiply this times 2. Okay, equals this times 2, and there you have it. Okay. I'm not sure why I have that there necessarily. So, okay, so it's that simple. If you label it like that and highlight it like that, it makes it a little bit easier. When we go to B, then it says determine the coefficient of multiple determination and interpret this value. So that's the r squared that we're going to be finding, and we'll do a decent amount with r squared here. And that's on middle of page 485. And again, this one's pretty simple because it gives us our data right there in that ANOVA. And here's the equation that we use, but the SSR then is simply the regression. If you go to the SS column, go down to the regression, and where those two intersect, 77.907, right, is my SSR. And my SST then is the total, which is 661.6. And it's just one divided by the other. Equals my SSR divided by my SST, and it gives me 11.8 or percent, 0.1177. Okay, what's that mean? Well, that r squared, when we interpret that, this is how much of the variation is due to the independent variables. Okay, and we'll end up using a decent amount of R-squared. We'll do some bigger data sets and whatnot where you'll get to see where that's important. But if your guys is again 11.8% would be pretty small. Kind of go back to that same interpretation. If you get closer to 50%, it's kind of the correlation one that we did. We're basically saying the same thing. If we're about 50%, it's kind of a moderate, and if we get above 60-70%, then it's a strong association. Okay, so on the bottom C it says determine the coefficient of multiple determination adjusted for the degrees of freedom. Good. We don't spend a ton of time on this one, I don't think, but you can go back and read about it and see the equation. You read about it starting on the bottom of 485 and 486. It gives us this equation. And so the R-squared in this case is equal to 1 minus this part. Okay, and again, that was the part underneath the square root, which I had here. So boom, I already got that done. Plus the SS total, which I have here, divided by n minus 1. Okay, so this one was pretty easy. I could just say this is equal to here, and this is equal to my SST, which I have. Okay, divided by, better use a parentheses here, n minus 1. Parentheses, enter, there you have it. Now I have to divide those two, right? Because there's the top part of the equation, here's the bottom part of the equation, so top part, bottom part. So equal to this one divided by this one. And then I have to subtract that. Oh, what did I do wrong here? SSE, I got this one divided by this one. Hang on, I did something wrong here. I got to figure that out. I just put it in the wrong place. I'm sorry. I had divided it here. This is equal to this one divided by this one. Okay, and then I have to subtract from 1. So I did, or 1 minus this particular answer here. Oops, I got to put my equal sign in there, don't I? Equals 1 minus. There we go. So 0.089 or 8.9%. So probably even a lesser association when we get to there. And that kind of explains that when it talks about the adjustment for the coefficient of determination.